So now let's say you want to add the following geometric sequence, right? We're still going to use the approach we used in arithmetic, just a bit different. How many terms are these? 1, 2, 3, 4, 5. So we have the sum of 5 terms, right? Now we can call it equation 1. Now here, instead of reversing this, just like we did this one, we're going to say what is equation 1 multiplied by the constant ratio, which is r. It's going to be s of 5 times r. It's what is our constant ratio here? First of all, what is our constant ratio? To get the constant ratio, remember you're going to say T2 divided by T1, T4, T3 divided by T2. So when you say T2 divided by T1, you get 4 divided by 2, which is 2. And then T3 divided by T2, it's 8 divided by 4, which is 2. So our constant ratio is 2. So it means we're going to be multiplying by 2, right? As our constant ratio. So s of 5 times 2, it's 2 s of 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Then this is our equation 2. Okay, this is our equation 2. Can you see that we have exactly the same numbers? Like we have exactly the same number of columns here. 1, 2, 3, 4, 5 columns. Okay, and in each one of the columns, we can most definitely see that we got the answers, right? So what do we then do when we have this? Check. This 4 is the same as this 4. This 8 is the same as this 8. 16 the same as 16. 32 the same as 32. The first term and the last one are the only ones that are not the same. Now what we're going to do is that we're going to shift these numbers. This is what we do. We shift these numbers, all of them, so that we align them. Check. When we shift them, we will have something like this. You see that? We'll have something like this. But it doesn't change anything. We just shifted them. What will happen is that here, it means here we have 0, right? When you name them, it means here, this is still equation 1. But here we have 0 here, right? It's 0, and even here we have 0 here. Okay, this is 0 there, but you don't write them. Okay, so we call this equation 2. Now we're then going to say this equation 2 minus equation 1. So we're going to say this minus that to be 2s5 minus s5. Then what is 0 minus 2? It's negative 2. 4 minus 4 is 0. 8 minus 8 is 0. 60 minus 16 is 0. 32 minus 32 is 0. 64 minus 0 is 64. Okay. And then after that, what do we then say? We can take out s5 as a common factor. We'll be left with 2 minus 1. Then here we have negative 2. Then this is all 0. So negative 2 plus 64 is 62. Then you divide all of that by 2 minus 1 by 2 minus 1. Therefore, the sum of 5 would be 62 divided by 1, which is 62. So it means when you add these 2 plus this plus that plus that plus that, it's 62. Okay, so the same thing we're going to apply it on a geometric, right? The first term of a geometric is a. Now remember that there is r here. We multiply by the constant ratio, so the second term will be ar. Then we multiply by the constant ratio, so the third term will be ar squared. Then you say plus, and then the last term would be ARN minus 1, which is Tn. Remember that Tn is equals to ARN minus 1. Okay? Then with that one, that will then be our first term, our first equation. Right? Then we're going to do the same thing we did before. We're going to multiply this by r. So we multiply equation 1 by r. Then we'll have this times that, it's r as n. Then a times r, it's ar. ar times r, it's ar squared. And then ar squared times r will be ar cubed. Sorry. It would be ar cubed. Yeah? Then you say, so what I'll advise you to do then, so that you get it correct from the get-go, you just follow this trend that we had here, that the first term is going to be like having a 0 on the bottom, then these numbers that are the same, you align them, and then the last one will be the one different from the rest. So this is what you do. You say this would be, you say a times r, it's ar. So here you're gonna write it here like this. You write exactly the same thing, but for the last term you're gonna say arn minus 1 times r. Arn minus 1 times r will then be arn minus 1 plus 1. Bases are the same, we add the exponents. So this will be arn. So that's your last term, arn, which is exactly the same as what? As 64. Alright. Then this is equation 2. Then after that, what do? You say equation 2 minus equation 1. Okay. So when you say 2 minus 1, you will have rsn minus sn. Then here you have 0 minus a, which is negative a. Then here you're gonna have 0, 0, 0 until a, and then you have 0 and then plus arn, because arn minus 0 is arn. Then now you can take out a common factor sn. You have r minus 1. Then here you can rewrite it as negative a plus arn, which is arn minus a, right? Then you can then say Sn would be, you can take out a as a common factor. You have a into rn minus 1. Then you can divide both sides by r minus 1. Remember, we had r minus 1 here. So we can divide both sides by r minus 1 by r minus 1. Therefore, your Sn would be a into rn minus 1 all over r minus 1. Then you have proved it.